Hello, astronomy and meteorology students. It's Mr. Johnson here to give you some notes on the characteristics of the atmosphere. If you need to pause the video now to get notes, either electronic or paper, you can totally do that. And remember that you can always go back and rewatch and pause anytime you need. So, the goal of today's video is to give you a foundational knowledge, a basic knowledge of three different characteristics of the atmosphere, so that you can apply them to information we will be going over later in class in the remaining time that we have, and so that you can apply those three bits of information to weather forecasts that you might look at in order to make informed decisions about your day. So these notes will be in addition to Edpuzzles that you will have watched that I will maybe refer to today. If you have not watched those Edpuzzles, make sure you go back and do that. Let's back up to the layers of the atmosphere, since that's kind of where we left off. The troposphere. Tropos means change, and it gets its name from the weather that changes within the troposphere. So let's think about it right now. What is the weather like where you are right now? If you were to go outside, how would you describe it? Warm, cold, windy? Would you talk about this wind speed? Is it humid where you are? Sunny? What kinds of things would you use to describe the weather? Well, the weather really has to do with the general conditions that are in an area at a particular place and time. So it's interesting, I can talk about the weather where I'm at, and sometimes I'll be talking to my mom, and the weather will be very different where she is, and she's only 10 minutes away. She's in Sioux Falls, not very far away. It's very interesting how that weather can be very different in a particular place or time. Now, when we talk about weather, that weather includes things like a measurement of temperature. It could be the wind speed, the wind direction. We could talk about the moisture in the air. We can even talk about the moisture in the air compared to how much the air can hold, how much moisture can be in the air. We could talk about air pressure. We could even combine things like moisture and temperature. So if it's really hot out and really moist in the air, then we might be discussing things like a heat index, where you might be given a warning not to go outside because it could be dangerously hot. So I'd like to teach you some information about that so you can have a better understanding about what that really means. Now, the key with weather is that it can and does change often, and it can change very quickly depending on where you are. And we know in South Dakota here, if you've lived here for any amount of time, you know that we can have it really nice, warm, sunny, and within half a day. It could be one day later or less, and it could be cold and maybe even potentially snowy. It's kind of crazy. Let's compare that to climate. So if you think back to those videos we watched, the big difference between weather and climate has to do with how much data we're looking at. Climate has to do with the average of those weather conditions over a very long time. If somebody asks you what the weather or what the climate is like, and you look out your window and describe it, well, you're talking about weather. You're not talking about climate. Climate scientists will look at average weather conditions over a very long time. They look at a lot of numbers and they average them out over 30 years. So that means that as they get new information, they drop the oldest information from that average. And this is why we can look at a change over time. As we get new information, as we get more data, more weather data, and add it to that average and drop off the old data, well, we see a shift in what that climate is doing. The types of properties that we're going to be talking about today, or that we will be covering, would be air pressure, temperature, and humidity. You've already seen a couple Edpuzzles over air pressure, and you will see at least one or two over humidity. So let's dive in. To start off, atmospheric pressure is based on the concept that air is made of mass. And we know this is true because the air essentially is a collection of gases like nitrogen and oxygen and carbon dioxide and water vapor and methane and all of these different gases. And they are all made of atoms, and atoms have mass, and mass is affected by the gravity of the Earth. Now, we can easily demonstrate that the atmosphere has mass by simple experiments. Like we can fill a balloon with air and measure that balloon before and after we put air in terms of its weight. And we know that there is more weight with an added air inside of it. If we were in class, we would do a few demonstrations of this, but unfortunately we're not, so I'll just kind of have to describe them. Another thing we could do is take balloons and blow them up to about the same size and balance them on sort of a teeter-totter, slowly deflate one balloon, and we would see that it rises while the balloon on the other end of the teeter-totter sinks closer to the Earth. Another kind of interesting demonstration where my students have broken a lot of rulers before is to take a ruler with about a third of the ruler sticking off of the edge of a desk, and you can put a one sheet of paper, pretty big, like one newspaper that's unfolded, one sheet of newspaper, not the whole thing, just one page, over the ruler along the edge of the desk also. And if you give that ruler kind of a quick and firm hit, you'll see that it doesn't lift that paper up. All of these demonstrate that the air has mass. The balloon falls to the Earth because it's been filled with air. The balloon with more air in it, when the other one is deflating, will sink closer to the Earth because it is the one with more mass. And the ruler demonstration, if you think about it, that really big paper and the relatively small ruler, there's a lot of air pushing down on a pretty big surface area of the paper. And when you take that ruler and try and give it a good hit, you're going to find that all of that air is pushing down, and that is more than the force that you've put on that ruler to try to move the paper off of the table. Now, there's a lot of mass that's relatively close to the Earth's surface. We measure that pressure in what's called millibars. The pressure exerted on the surface the pressure that's exerted on the surface of an object by the weight of the atmosphere is measured in millibars, and we actually know that the air pressure is related directly to the air density. So the closer you are to the Earth's surface, the higher the air pressure will be. The further away you get from the Earth's surface, the lower that air pressure will be. Now, you may be familiar with this in a few different ways. If you've ever flown in an airplane, you may not have realized, but they pressurize the air cabin, the airplane cabin, because they're flying pretty high, kind of that troposphere, stratosphere, the tropopause level, and kind of a little above it to avoid that weather. And the air is a lot thinner up there, and so the air density is a lot thinner, and they have to then account for that and maintain what you're used to on the Earth's surface. So they pressurize that cabin. Other examples of that would be, people that are climbing Mount Everest. They oftentimes have to use supplemental oxygen to help them climb because the air is so thin that there's not much oxygen available to them. Now, I have not been on Mount Everest, but I'm guessing it's really, really thin air feeling. I've been to much, much lower places, like 14,000 feet up in mountains, and it's remarkable. It's crazy how much the air actually physically feels thinner and lighter on you. It actually, you can feel the thinness of the air. It's pretty cool. The key here is that with an increase in altitude or elevation, you have a decrease in air pressure because that air becomes thinner. So when we talk about air pressure, it's a discussion of the weight of the atmosphere compared to the surface that we're discussing and how big it is. And as we just talked about, the atmospheric pressure is lower at higher altitudes, and so the atmospheric pressure would then be higher at lower altitudes. A barometer can be used to measure the atmospheric pressure. There's two types of barometers that you learn about. One is a liquid barometer. This barometer works based on the concept of the air pressure that is being put on a liquid causes that liquid to rise a certain distance up into a tube. Now, this liquid originally was mercury, which is where we get this really kind of historic measurement of atmospheric pressure in terms of millimeters of mercury, or mmHg. And we won't get into it too much, but we can get into there is a discussion of we can measure atmospheric pressures in terms of the number of atmospheres. There's, I don't know, all sorts of different ways. The liquid barometer, by the way, it no longer uses mercury because it's not healthy at all. So there's other substitutes that can be used. Now the aneroid barometer is most used, only second to other digital barometers that you can find. Aneroid barometers are kind of cool. If you've never seen what it looks like, this picture on the bottom right, and aneroid means without liquid. And the reason it gets that term or that wording is because there is a sealed container that will actually be affected by air pressure, and it will change its shape, and that shape will then adjust a dial that you can see in the bottom right to sort of a set scale that will tell you what the air pressure is. And the reason we care about our air pressure has to do with these things called air masses. If the air pressure drops or rises dramatically, then I know a new type of air mass is moving in, and as it does so, it tends to bring certain weather with it. And so we'll hopefully have a chance to talk about that a little bit later. I'm not going to show that video to you. You've already can move on, maybe. In terms of layers of the atmosphere, the pressure decreases at a predictable rate as you increase in altitude. The reason that we have different layers of the atmosphere have to do with distinct changes in temperature that we will discuss a little bit later. Actually, you've already discussed them in past things that we've done in this class. And so I'm going to pause this video here. I'm going to stop it. We'll talk about temperature a little bit later.